Hello, in this lesson we're going to be looking at polynomial functions and we're going to learn how to further analyze them just by looking at the equations. Some vocabulary words that you're going to want to be familiar with in this lesson would be, first of all, a monomial. That is a number, a variable, or a product of numbers and variables. And here's some examples. Here you have a number, here's just a variable, and this is the product of number and variable. A polynomial is a monomial, or the sum of monomials. Like here, for example, we have 2x squared minus 3. Now, this particular example is called a binomial because there are two terms. If there are three terms, it is called a trinomial. Polynomial functions are typically in this form where you have the highest exponent first and then they are in descending order. At the end, you have just a constant, just a plain number. The number in front, when it is arranged in the right order, is called the leading coefficient. Now here's an example. The highest exponent here is 4, and so we would call that the degree. And then you'll notice then it's x cubed, x squared, x to the 1 power, and then it's just a constant. The number in front is 3. That is the leading coefficient. One thing to remember is that with polynomials, the exponents are always whole numbers. So we're going to just fill out a chart and use some of these terms to describe polynomials. This first one is a constant. You'll notice there isn't a variable, or if the variable is there, it's to the 0 power. So this is called a constant because it's degree 0. Degree is the highest exponent. In this case, we just have one term, so we would say it's a monomial. Oh, I should have put that right there. So one term, so it's a monomial. Next one, we have two terms. The highest degree is 1. So we would say that this is a linear equation, a linear polynomial. So there are two terms here, so this is a binomial. Next, the highest exponent is 2, so that is the degree, and we would say that would be a quadratic polynomial. And this one again has two terms, so again we would call that a binomial. Next, the degree is 3. A third degree polynomial is called a cubic function. This particular equation has 3 terms, and so that is called a trinomial. Here we have another that has 3 terms, so again it's a trinomial. And notice the degree here is 4. Polynomials that are 4th degree are called quartic functions. If you have a 5th degree, it's a quintic function. This one has 3 terms, so it was a trinomial. This one has 4 terms, so we would just say it's a polynomial with 4 terms. My pen is not working real well today. Hopefully it'll cooperate through this lesson. Okay, here it says to write each polynomial in standard form, which means the exponents are in descending order. And what is the classification of each polynomial? By degree and by number of terms. So first, the highest power here is 9x squared, so we'll write 9x squared. And then plus 3x to the 1 power, and then plus 5. So that would be standard form. And what is the classification? Since it's 2nd degree, it would be quadratic. And the number of terms, it's a trinomial. Next, we have 5x to the 4th plus 3x to the 3rd, and then this is an x to the 1, so that's the last. And this is a 4th degree, so this is a quartic. And since there are 3 terms, that would be a trinomial. Next, we have x to the 4th, that's the highest power, that goes first. And we have minus 6x to the squared plus 10x squared, so we'll combine those. So that would be a positive 4x squared because 10 minus 6 is 4. And then we have 4x, and then we'll end with the constant, which is negative 12. And this is also a quartic function, and it's a polynomial with 4 terms. All right, now we are going to explore end behavior with polynomials because they all follow a similar pattern depending on what the degree is and the leading coefficient. So let's just look at this equation. This is a linear function right here. The exponent is 1. And if we were to graph it, the y-intercept is 2. We would go up 3 over 1 or down 3 back 1. Now my pen wouldn't work and now it's going like crazy. Okay, so if we draw that line, we'll notice that as our x's are increasing, the y's are also increasing. So this end goes up. Here, as our x's are decreasing, the y values decrease. So this end is going down. Let's look at this next one. Now here we had a positive 3 in front. Here we have a negative 2 in front. And again, it's a linear. Exponent is 1. Y-intercept is 2. So the slope is down 2 over 1. So this has a negative slope. And so as our x's are increasing, our y's are decreasing. So this end is going down. As our x's decrease, the y's increase. Now, what I want you to notice is here you have an odd number for an exponent. So when the exponent is odd, here we have a positive. And so we have the pattern down on the left, up. So this is a down, up. Here, the leading exponent is a negative. And now on this side, we are up. And on this side we are down. So we're just looking at that pattern because whenever you have odd exponents, it's going to act that way. In this next example, we have x squared. Both of these examples are x squared, so that's quadratic. And the exponent is even. So we're going to watch what happens. So here your leading coefficients are 1. Now if we'll recall here, when we are graphing quadratics, we typically will start by finding the axis of symmetry, which is negative b over 2a. Here's your a, here's your b, here's your c. So that would be negative 2 over 2 times 1. So that would be a negative 1. So we'll go to negative 1 and draw the axis of symmetry. I'm just going to make it a dotted one here, just draw it lightly. And then we'll plug that into the equation. So that would be 1 squared plus, let me go back here. 1 squared plus 2 minus 4. So that would be 3 minus 4. That would be a negative 1. So your vertex is going to be right here. And let's just plug in 0. That would give us negative 4. And then we'll reflect it over. Whoopsie, something is wrong here. 0 plus 0 minus 4. What happened when I plugged in? Oh, this is what's wrong. This is a negative 1. Let's just back up here. That was not turning out. I knew I had a mistake here. So the axis of symmetry is at negative 1. And now when we plug in negative 1, let's go back. So this would be a negative 1 squared is a positive 1. Minus 2 minus 4. So minus 1 minus 5 is a minus 6. That looks better. And then if we plug in 0, we'd get a negative 4 and we'll reflect that over. So this one's going to look like this. All right, so we'll notice as your x's are decreasing, your y values are increasing. And as your x inputs are increasing, your y values are also increasing. So here, when we have a positive in front, the left side opens up and the right side opens up. So we have an up-up pattern. So that's when we have a positive in front. Now let's look at the next one. Again, we'll do x equals negative b over 2a. We'll see if I can graph that one right. So that would be a negative 2 over 2 times negative 1. Negative 2 over negative 2, that's the positive one. So we'll draw it on this side. And we'll substitute in that number. So we would have minus, and then 1 squared is 1, plus 2 minus 4. So that would be 1 minus 4, that's a negative 3. And now we'll substitute in 0, so that would be 0 plus 0 minus 4. There we go. Now we're going the right direction. Now, as you can see, as your x's are decreasing, the y values are decreasing. Here, as your x values increase, the y values decrease again. So in this problem, when the leading coefficient's negative, the ends are down and down on the right and on the left side. So, like I said, all polynomials that have even degrees are going to act like one of these two, or if they have odd degrees, they're going to act like one of these two. So here are some examples. Now, realize that the degree of the polynomial affects the shape. For example, when we have quadratics or we have an even degree, you have either an up-up or a down-down pattern. When you have an odd degree, you have either a down-up or an up-down pattern. The polynomial affects the shape, whether you have curves or just straight lines. It also affects the maximum number of turning points. And the formula for the maximum number of turning points is n minus 1. So in this case, your n is 2. So it would be 2 minus 1. You would have 1 turn. So as you're moving one direction, and there you turn. So again, this is n minus 1. 2 minus 1 is 1 turn. So you're going in a direction, and then you have a turn. Here, if n minus 1, 1 minus 1 is 0. You have 0 turns. And also the degree, like we said, affects the end behavior, whether it's up, up, down, 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 up, or up, down. So the pattern is if the degree is odd and the leading coefficient is positive, this end will be down, this end will be up. So again, down, up, down, up. Doesn't matter how many turns are going on in there. That's going to be affected by the degree, but your end behavior will always be the same if you have an odd degree with a positive leading coefficient. For example, this might be y equals x plus 1. It could be an equation like that. This could be y equals x cubed plus 2, something like that. This could be y equals x to the 5th, something in that order, with maybe some more numbers there following. So here we have an odd degree, a negative leading coefficient, and this is going to be up, down. So up on this end, down on this end, up on this end, down on this end, up on this end, down on this end. So this would be like a y equals a negative x plus 1. So notice the leading coefficient is negative. This could be y equals a negative x cubed plus something, and so on. This could be y equals a negative x to the 5th plus something. All right, when your degree is even and the leading coefficient is positive, you're going to have up, 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 up in behavior. So this might be y equals x squared plus 2x or something like that. This would be y equals probably an x to the 4th. This might be another y equals x to the 4th. And then here we have even degree, and with a leading coefficient that's negative. So it's a down, down pattern for the end behavior. So this might be a y equals a negative x squared. This might be y equals 1, 2, 3, x to the negative x to the 4th plus something. And here are just some more patterns. This equation is x to the 4th. It's even, and it starts with a positive, so it's going to be up, up. Sure enough, up and up. And x to the 4th, so if we look at the number of turns, it's n minus 1. So 4 minus 1, there are 3 turns. So sure enough, you're moving one direction, and here's a turn, and here's a turn. 3 turns. This is x to the 5th, so that's odd, which tells you you're going to have an up, down, or a down, up. And since it's positive, it will be like you have a positive slope. So this ends up, this ends down. So down, up. And x to the 5th, n minus 1 turn, so there would be 4 turns. So there's a turn, there's a turn, there's a turn, and there's a turn. And then here we have a negative x to the 3rd, so it's odd, which is a down, up, or an up, down. And since it's negative, it would be like, think of a negative slope. So this end is up, and this end is down. And here we have x cubed, which is odd, so it's up, down, or down, up, but it's a positive coefficient. Lines that have a positive slope are down on the left side, up on the right, so this is down, up. Here we have a couple graphs to look at, and it's for x to the fourth, so even degrees, so up, up, or down, down, and since it starts with a positive, it's up and up. And there are some turning points here, and we can look at when the function is decreasing or increasing. So as our x values go from negative infinity up to this turning point, we would say that your y values are decreasing. As your x function goes from right here to right here, or as your x values go from here to here, the y values are increasing. Here it is decreasing, and the y values from this point to positive infinity are increasing. The next question says, consider the leading term of each polynomial function. What is the end behavior of the graph? Check your answer with a graphing calculator. And so since this is odd, it's going to be up, down, or down, up. But since it's positive in front, like a positive slope goes this direction like you're climbing a hill. So this is going to be down on the left side and up on the right side. And here, this is an even degree, so it's either up, up, or down, down. And since it's a negative out front, it's going to be down, down. And you can also plug those into Desmos, those equations, and you'd be able to see what those end behaviors are doing. Here's a few more here. It is, what is the graph of each cubic function? What are the end behaviors? So what we can do is we know we can just make an XY chart here and plug in some numbers. Like if we plug in 0, we would have 0. Let me see, if we plug in 1, we would have 1/2. If we plug in -1, we would have a -1/2. If we plugged in, let's say 2, 2 times 2 times 2 is 8, times 1/2 is 4. And if we plug in a -2, that would give us a -8 times 1/2, that would be -4. So it would look like this. And this, the end behaviors here, we're down on this end, up here, so this is a down, up. So basically an increasing slope. And there are n-1 turning points, so we would say 2 turning points. Here, first I'm going to put this in standard form. And we're not going to take the time to graph it, but you could make an XY chart. But we know that if it's an odd degree with a negative out front, it's going to be like this, have like a negative slope. So it will be up on the left and down on the right. And there would be n-1 turning points, so 2 turning points. And that's it for this lesson. Let me know if you have questions. Thanks for watching.